Welcome to ChemHelp ASAP. Now we know how to count electrons in atoms. We simply look at the periodic table, look at the group number, and the group number tells us everything we need to know about the number of valence electrons in that atom. However, when atoms are incorporated into molecules, they form bonds, they have lone pairs, and we have to have a new way to count the valence electrons because these atoms form molecules in order to achieve and satisfy the octet rule. So on the screen we have 4 different molecules, and these are 4 Lewis structures of molecules, and we're going to use these structures to count valence electrons. And hopefully all these molecules satisfy the octet rule. So how do we count electrons? Well, bonds in a Lewis structure, and these are the lines, these count as 2 electrons towards our octet rule. And lone pairs, which are the 2 dots, these count towards 2 electrons. So to achieve the octet rule, to satisfy the octet rule for these elements, we need any combination of 4. And that's 4 bonds or 4 lone pairs or 2 bonds and 2 lone pairs, what have you. So here we go. Here's a simple structure. This is methane. And here is our carbon. And this carbon has 4 bonds because there are 4 lines to that carbon. That is 8 electrons. Fantastic. Here is ammonia. Technically not an organic molecule, but a molecule commonly encountered in organic chemistry. It has 3 bonds. Oops, not bones, 3 bonds, and 1 lone pair. That is 8 electrons. Fantastic. Now, here is hydrochloric acid, HCl. Chlorine, which is a 3rd row element, but chlorine very often behaves just like a 2nd row element in terms of the octet rule. Chlorine has 1 bond and 3 lone pairs, and that gives us 8 electrons total. So that satisfies the octet rule, the chlorine does. And finally, this molecule at the end, formaldehyde. Formaldehyde, the carbon, has 4 bonds. That's 4 lines. Now, the carbon, it has a double bond to oxygen. That counts as 2 bonds. It's 2 lines in that bond. So that's 4 bonds, 4 lines, no lone pairs. So that's 8 electrons. And the oxygen has 2 bonds, 2 lone pairs, 8 electrons. Fantastic. Now, you notice we have hydrogens in all these molecules, and we don't talk about the octet rule for hydrogens. As it turns out, hydrogen follows something that calls the duet rule. Not nearly as well known as the octet rule, but the hydrogen likes to have 2 electrons in its valence. And if you look at all these structures, the hydrogens have 1 bond, 1 line, that's 2 electrons, so hydrogen satisfies the duet rule. So if we have a Lewis structure that's fully drawn out with lone pairs, we can very quickly count those electrons and make sure that all these 2nd row elements, or the hydrogens, or halogens, or maybe the sulfur and phosphorus, that they have the right number of bonds and lone pairs to satisfy the octet rule.